Hi all, see this, in this particular problem we are asked to check the differentiability of the function in general at the point x equal to 0 and x equal to 1. So, we will all consider the neighborhood of x equal to 0 and x equal to 1, that's the important constant, right. Now here we'll solve this problem by testing, okay, all other options, right, without going ahead and prove it in general way, okay. So let's go ahead and concentrate about the option 1, okay. Now in option 1 it says that a equal to 0 and b equal to 1, okay. So therefore my given function fx, let us take that as option A. We are actually testing that option. So therefore my function fx will be reduces to a is 0 and b is 1. So therefore in this case we'll say that this portion is goes off, so we'll have that only other part. So therefore we can say that this actually gives you b mod of x and sine of mod of x cube plus x. So that's our function, okay. So now we need to test that at the nearest point of x equal to 0, okay. So that's it, okay. So here we will consider that x tends to 0 case, that is in the neighborhood of x equal to 0, that is in the interval x minus some h, 0 minus h and 0 plus h, right. In this interval only we are trying to observe that function, not anything else, okay, because then the problem became little complicated and all that. So that's why we are concentrated on this interval only, okay. So here also there is two cases, right. One is x greater than 0, x less than 0, right. So therefore if I trying to consider that x greater than 0 case, obviously here we have to understand that our x lies in this given interval. Now x greater than 0 means that obviously we can say that the given function fx is reduces to b is 1 is given. So therefore we can say that it's actually mod of x. So that mod of x will be reduced to, right, as x, because by the definition of mod x. And also when x is greater than 0, right, we can say that x cube plus x is also greater than 0, and that's why we'll say that gives you as sine x cube plus x. So that's it. If I consider the condition that x less than 0, so in that case my fx will gives you as minus x, and x cube plus x is less than 0, because for a negative values of x both are negative. So therefore that function will be reduces to sine minus x cube minus x. Now sine of any function with minus is positive, so therefore we'll write down as sine x cube plus x. And that's it. So therefore we can easily observe that, right, the given function, okay, are actually became the same form in the neighborhood of x equal to 0, right. So if I calculate the right limit or the left limit, we have to choose this function, okay. So at this function it is obviously a sine function, so it is differentiable. So we'll say that function fx is differentiable at x equal to 0 for a is equal to 0 and b is equal to 1, okay. So that's it. So therefore we can easily say that for this particular case, right, that option A is correct. Here I can remove that because b is 1, okay. So that's it. So therefore we can say that option A is the correct option, but that is not done, right, because some problem in JEE obviously will have that multiple option may be correct. So that's why we have to check the other options as well. So let's go ahead and check that option B. So here it says that x equal to 1, a equal to 1. So therefore in this case obviously my function fx gives you cos of mod of x cube minus x, right. Now here we have to test that for x equal to 1 case, right. Now at x equal to 1 means that here we are trying to say the condition, the case x tends to 1, that is we are looking in the interval one minus h to 1 plus h. Obviously, h is tends to 0 or h is very small, okay? That's it. Now, if I go ahead, we have to check this function, right? What is x cube minus x at this case, right? So, first we consider this x cube minus x and let us observe that, right? Now, see that. That if I consider that x cube minus x and equal to 0, that's imply that it's x multiplied by x squared minus 1 equal to 0. That's imply that zeros of this function is x plus 1, x minus 1. And that's why the zeros are actually x is equal to 0, plus 1 and minus 1. So why we need that? Because I need to sketch that x cube minus x, because always sketching gives me the easiest way to interpret the answer of the problem. So here marks that. So this is minus 1, 0 and 1. We'll see that at any point at x equal to minus 2, the function value is negative. Taste that it is minus 8 and plus 2. So it's negative. So therefore we can see that our plot of this function will be something like this. Okay. So therefore we can understand that 1 plus h, right? X cube minus x is actually positive, 1 minus something, it is negative, right? But in any cases, let's write down that. So therefore it's imply that x greater than equal to 1, x cube minus x is actually greater than 0, and x is less than 1, x cube minus x is less than 0. Okay. Now, only one case you have to test that. Wherever I wrote that x greater than equal to and all that, we have to see that this is the interval we are talking about. That means x less than 1 means is actually that it's less than 1 but not exceeding that limit. So it's actually talking about closing to that plus 1. Otherwise, obviously the function will change as obvious from this function. So in both cases, we can see that function fx is equal to cos of x cube minus x when x is greater than equal to 1, and obviously that cos of it is the of minus x cube minus x when x is less than 1. Now see that in that case, right, cos function cos minus x is also positive. Therefore we can easily step jump one step and say that this actually gives you the same function. Okay, so that's why again we'll say that the function fx is differentiable at x is equal to 1 for a is equal to 1, b is equal to 0. So the second option is also correct. Now we will have two other options left. So C and D, that option need to be checked based on the similar approach. So let's go ahead. Now here it says that for C, it says a1, b0. So therefore my function fx will be reduces to a. So a will be not there because a is equal to 1. So I just remove that, and then it gives you as cos mod of x cube minus x. So that's my function. Now we are looking for x equal to 0, right? So now we can see from this function itself, we can understand that if we are talking about that interval, so x tends to 0 case, that is inside the interval 0 minus h and 0 plus h. Now in this particular interval, see from this plot, right, 0 plus h, the function is negative, and 0 minus h, the function is positive. So therefore we can say that based on the similar approach, we can say the function fx is equal to cos of x cube minus x when x is greater than equal to 0. And also we can say the same function repetition of the function x cube minus x when x is less than 0. We can conclude the same kind of phenomena, say stating that cos is a even function. So as it's an even function, so therefore less than 0, greater than 0, the values will be very similar, right? So therefore we can easily say that that function is differentiable. So therefore here also we can say that that's imply fx is differentiable at x equal to 0. But here they give it as not differentiable. So therefore obviously that for option C is false. Test for the next one. But next one is the combination of both. So we can consider that fx is equal to a cos of x cube minus x plus b of, so I just write mod x sine x cube plus x. Okay. Here this one need to be removed and the mod need to be present. So this should be mod, not that open bracket. Okay. Now see that. Now what case we are looking for? In that particular case, we are looking for to find this testing and all that stuff with respect to the point x equal to 1. Now look carefully. At x equal to 1, that x cube minus x is already written, right? So whatever happened, one plus case or one minus case, cos x cube minus x always gives you the same value, right? Near about that. Now we have to test it for x cube plus x. Now let's see that x cube plus x. Now if I go ahead and trying to plot x cube plus x, right? So see that x cube plus x means x taken common, x square plus 1. That means here we can have this plot like something like this, right? Because only the function has a roots at x equal to 0. The remaining roots are complex, right? So this can obviously the possible plot of x cube plus x, right? Now see that here we'll talk about x equal to 1. So therefore if I talk about x equal to 1, right, it is always positive. So therefore that x cube plus x is become always positive and mod x is always positive. So therefore we'll say that in the neighborhood of, so neighborhood I just wrote by NBD here, neighborhood of x equal to 1, that cos mod of x cube minus x will be equal to cos of x cube minus x, and that mod x of sine of mod of x cube plus x will be equal to, the mod cannot be there because both are positive. So therefore you can say that it's x cube plus x. So therefore fx is became cos x cube minus x plus x into sine of x cube plus x in this neighborhood of x equal to 1. Now it is obvious that if I go ahead and take that neighborhood function, right, it is obviously differentiable. So we'll say that here also fx is differentiable. So that's it. So therefore that option is also wrong. So therefore for this particular problem, obviously option A and option B are the two correct options. And that's it. Hope you understood the problem. Thank you. Hi all. See this, in this particular problem we are going to find out the normal of the slope. That means we have to find the slope of the tangent first, right? Then only obviously we can go ahead and calculate the normal. So how we find the slope of the tangent? Obviously we have to go ahead and find f dash x. Now see that the function is not very simple, right? Calculating f dash x by the normal differentiation approach, it takes longer time. So first job is to simplify the function. So let's go ahead and simplify it. So here we consider that fx is equal to tan inverse of, and then we have square root of 1 plus sine x and 1 minus sine x. Okay, now see that in this case, right, that 1 can be easily replaced as by a trick that it is cos square x by 2 plus sine square x by 2 plus, and sine x can be written as 2 sine x by 2 and cos x by 2. That's it. We can write the denominator also under the square root in the same way. So here we have to write cos square x by 2 plus sine square x by 2, and here instead of plus sign we'll have minus. So minus 2 sine x by 2 and cos x by 2. Now see that, right, that it gives you actually a plus b and a minus b whole square formula. So therefore we can say it is square root of cos x by 2 plus sine x by 2 divided by cos x by 2 minus sine x by 2, but whole square is included. So obviously now we can eliminate that square root. So before eliminating that, we can eliminate that square root. Now before elimination, we can also divide both sides by cos, right? So if I go ahead, we can find it is 1 plus tan x by 2 1 minus tan x by 2. Now tan x by 2 we can write it as 45. So it's tan inverse of tan pi by 4 plus tan x by 2 1 minus tan pi by 4 and tan x by 2. So now we recall the formula of tan a plus b. Now if I see that this is the formula of tan a plus b, so therefore we can say fx now reduces to tan inverse of tan of pi by 4 plus x by 2. So therefore it is obviously possible that our given function is reduces to a simple pi by 4 plus x by 2. So it's a linear function, okay? So now we have to find the slope. What's the slope of the tangent? F dash x. So therefore we can say that f dash x is equal to 1 by 2. What's that? This gives me the slope of the tangent at any point to the given curve. So therefore we can say that slope of the normal, let us take it as m, that's equal to minus 2, because slope of the tangent and normal will be minus 1 because they are perpendicular to each other, right? The product of the slopes will be minus 1, okay? That's it. Now we have to find the equation of the normal. So one point is already given, that is x equal to pi by 6, right? So obviously we need to find the coordinate, so that point will be a for pi by 6. So let's calculate that. What is a for pi by 6? So that actually gives you pi by 4 plus pi by 12. So if I add it by normal LCM technique, so 12 is the LCM, we'll get it as 3 pi. So 4 pi, that's pi by 3. So therefore we are required to find out the normal with slope minus 2 and passing through pi by 6 and pi by 3. That's it. Now obviously we can see that normal is a straight line, obviously. So we can follow the equation of the straight line to find out the normal. Let's go ahead. So therefore we can say that it is y minus pi by 3 into minus 2 into x minus pi by 6. Let's go ahead. We can say that it is y minus pi by 3 is equal to minus 2x plus pi by 3. That gives you that y plus 2x and is equal to 2 pi by 3. That's actually the equation of the normal. Now see that between all other options, right, only 0 and 2 pi by 3, that's obviously lies in this line, right? So therefore, we'll say that option B here is the correct option. Why? Because here we can write that if I substitute that x equal to 0 and y equal to 2 pi by 3, it's lies on normal. Just direct substitution gives me the result, and that's it. Hope you understood the problem. Thank you. Hi all. See this, in this particular problem, we are asked to find out the minimum area. That means it's a maximum minimum problem or an optimization problem. Okay. So here is a problem of application of derivatives. Okay. Now here few information is given. It says that we have a wire of 2 units length and it's actually bended to create a circle and obviously a square, right? So therefore, the perimeter of the circle plus perimeter of the square will be equal to the wire length, right? So that's the first given condition. So we'll say that. So therefore, we'll say perimeter of the circle plus square is equal to the length. That's it. So that's imply that let's go ahead and find out the perimeter of the circle. That gives you 2 pi r. And perimeter of the square, that means total length 4x, that's equal to 2. Okay, let's divide both sides by 2. So therefore pi r is equal to 1 minus 2x. That's imply that r is equal to 1 by pi 1 minus 2x. So this is the relation we'll use later. Now it says that what we need to minimize. We have to minimize the sum of the areas of the square and the circle. So therefore we'll find that sum of the area of circle and square. So let us take that as z. So therefore z is equal to circle area, that is pi r square, and obviously x square. Now our job is to minimize that. Just replace that by r equal to this. So therefore pi multiplied by 1 by pi square, and we have 1 minus 2x whole square plus x square. That's it. Let's go ahead. So therefore we can say that this gives you as 1 by pi a minus b whole square formula. So 1 plus 4x square minus 4x plus x square. So that's imply that if I write down based on the coefficient, we can find 4 by pi plus 1 multiplied by x square minus 4 by pi into x plus 1 by pi, and that's it. So this is my function z. Okay. Now our job is to minimize this function z. So how we minimize that? We have to find z dash and z double dash. So let's calculate that. So the differentiating with respect to x, we'll find z dash is equal to 4 divided by pi plus 1 multiplied by 2x. It's e minus 4 divided by pi. Z double dash is equal to 4 by pi plus 1 multiplied by 2. So it is always greater than 0, right? So that's a very easy job, right? So we need to find out the critical point. What is the critical point that gives z dash equal to 0? Let's go ahead. So for the critical point, z dash is equal to 0. That's definitely imply that z dash equal to 0 means 4 by pi plus 1 multiplied by 2x. That's equal to 4 by pi. So therefore we can say that if I added pi plus 4 multiplied by 2x is equal to 4 by pi. That's imply that x is equal to pi get cancelled. This is 2. So 2 divided by pi plus 4. So that's my x. Okay. Now we have to calculate the value of r. Okay. And you see that z double dash is greater than 0 always. So that is not necessary here, but let's calculate that. Now z double dash is greater than 0. That means that is z is minimum for x is equal to 2 divided by pi plus 4. Now at that particular point we need to calculate what is r. Let's go ahead and calculate r. So we will use this relation. So that gives you 1 by pi 1 minus 2x. So 1 minus 4 by pi plus 4. If I calculate, we can see that we'll get it as 1 by pi. Pi by 4 is actually the LCM pi plus 4 minus 4. That gives you actually 1 by pi plus 4. So now see that it is obvious that x is equal to 2r. So therefore the radius, that ratio of x and 2, or in other way we can see that square side is actually the diameter. Obviously you can understand that option C is the correct answer. So therefore option C is the correct option, and that's it. Hope you understood the problem. It's just a direct application of derivative, and so that's it. Thank you. Hi all. See this, in this particular problem we are going to find out the least value of alpha such that the given function is greater than 1. Function means that. So let's go ahead and reformulate this problem. So here we consider that fx is greater than equal to 1 where fx we just considered it as 4 alpha x square plus 1 by x, and that's it. Now here the function is greater than equal to 1. That means all the value, whatever the value is substituted in the case of x, right, will get the value greater than 1. That means minimum value of fx is actually greater than 1. So therefore it's imply that minimum value, I just read mean for it. So mean value of fx is greater than equal to 1. How we calculate the mean value? Let's test it. So therefore we need to calculate f dash x. F dash x is actually 8 alpha x and minus 1 by x square. Let us go ahead and calculate f double dash x. That actually gives you 8 alpha plus 2 divided by x cube. That's it. Now for critical point, we just consider f dash x is equal to 0. Now as f dash x is equal to 0, we'll find 8 alpha x minus 1 by x squared is equal to 0. That's imply that 8 alpha x to the power cube minus 1 equal to 0. That's imply that x cube is equal to 1 by 8 alpha, and in other way x is equal to 1 by 2 to the power alpha to the power 1 by 3. That's it. So this is the critical point. Now also notice that for the critical point we need to consider the conditions such that f dash x doesn't exist, and f dash x doesn't exist for x equal to 0. Okay, but still as the domain of the function is given as x greater than 0, so that's why we don't consider those points, right? So only one critical point is exist. Let's calculate and check that value at f double dash 1 by 2 alpha 1 by 3. Now obviously it says that it is 8 alpha plus now 2 by x cube. So 2 by x cube means 1 by x cube is 8 alpha. So therefore it will gives you as 16 alpha, and that is greater than 0. So we'll say that the function fx have mean value at x is equal to 1 by 2 alpha to the power 1 by 3, and that's it. Now we need to calculate the mean value. So let's mean value, that is actually gives you f of 1 by 2 alpha to the power 1 by 3. So let's calculate that. So that means we have to substitute x values here. So before substituting, we just write down the function as 4 alpha x cube plus 1 divided by x. That means that 4 alpha, what is x cube? It's 1 by 8 alpha plus 1. And now we have x. What is x? X is equal to 2 alpha into 1 by 3, right? So 2 alpha 1 by 3. So that gives you as, this is half, so 3 by 2 into 2 to the power alpha 1 by 3. That gives you 3 alpha 1 by 3. Now, this is actually the mean value of fx. So what is the condition? It says mean value of fx is greater than equal to 1. So that's why we'll consider 3 alpha to the power 1 by 3. So 3 alpha 1 by 3 is greater than equal to 1. That's imply alpha 1 by 3 to the power is greater than equal to 1 by 3. If I cube both sides, alpha is greater than equal to 1 by 27. So that's why the least value of alpha will be definitely option C, and that is 27, 1 by 27, and that's it. So that's the problem for you. Only we just apply application of derivative and get it done. And hope you understood the problem. Thank you. Hi all. See this. This is a problem of limit, and also we'll take it as in a different ways, right? So let's go ahead and understand the problem first. So let's take that limit as p. Okay. So what is the limit here? So the limit p is actually limit n tends to infinity 1 bar n plus 1, n plus 2 dot dot to 3n divided by n to the power 2n, and that's whole to the power 1 by n. That's it. So let's go ahead. So that's implied limit n tends to infinity n plus 1, n plus 2, and how can we get n plus 3n? So that means n plus 2n divided by n to the power 2n, and that's it, whole to the power 1 by n. So you can easily understand that in that product we are having 2n times, right? 2n terms, right? 1, 2, 3 is like that. We have 2n terms, right? Now to find that, we just take n common from everywhere. So that's imply limit n tends to infinity. N common from the first one, we'll get it as 1 by 1 plus n. We'll get 1 common again, so we'll get it as 1 plus 2 to 2 by n, and so on. So if I go ahead, we can write 1 plus 2n divided by n, and that's it, divided by n to the power 2n. Now see, everywhere I take n common, right? From first, second, third. So how many times we n common? We take n common 2 times, right? Or 2n times. So therefore, we can easily write this is n to the power 2n, and hence that 2n terms get cancelled, right? So therefore, my limit can be easily written as limit n tends to infinity 1 plus 1 by n. It's a product of 1 plus 2 by n, and so on. It ends with 1 plus 2n divided by n, and that's it. Now, obviously, you see that for product, the calculating limits and everything became little difficult. So we'll take logarithm, that natural logarithm on both sides. So if I take the natural logarithm, that means ln p is equal to, now see that if I apply natural logarithm here, right, obviously that using power law, that 1 by n came outside and log is applied here, right? And we know that log a, b, c can be written as log a plus log b plus log c, right? So therefore we can say that the given limit can be easily converted to as limit n tends to infinity 1 by n summation of 1 plus r by n, and here we can find that obviously I missed that log here, so add its r goes from 1 to 2n. Now see, r is 1 here, so we'll get the first term. I'll get 2n here, we get the last term. So that's why r is limit from 1 to 2n, right? And wherever we get this problem in this form, we already learned that how, or maybe you learned that how to convert a summation, right, in a integrations form, right? So wherever you see 1 by n, this term, only 1 by is present, there we just write it as dx dy or anything, and wherever we have r by n term, we need to replace it by x, some variable, right? So therefore, this limit can be converted as ln p integration of log of 1 plus x dx, and limit, it is 0, here 2n, that's why we'll write 2. If it is 3n, we'll write 0 to 3. If it is a 5n, 0 to 5. So that's it, okay? So now we are going to find out this limit, right? Now see that this integration need to be performed using integration by parts, right? So let's go ahead and find this integration using integration by parts. Let's go ahead. So I'll do that first without the limit, that easy for us. So log 1 plus x dx. that's definitely equal to log 1 plus x will be kept aside, and d dx integration of dx, that gives you x, with a minus sign integration of d dx of 1 plus x, that log x, that gives you 1 plus x, integration of x, that gives you x, and dx. Now this second integration now can be performed as x log 1 plus x. The second integration, we just write it as x plus 1 minus 1 divided by x plus 1 dx. That's imply that x ln 1 plus x, sorry, integration of dx minus integration of dx by x plus 1. That finally gives you x log x plus 1 minus x minus log of x plus 1. That's it. So this is the final integration. Now obviously we need to find ln p by substituting this limit, right? Let's go ahead. So therefore we will find that ln p is equal to, let's go ahead, 0, we just substitute 2. So therefore we get ln 3, 2 ln 3 minus 2 minus ln 3. And if I for 0, every gate 1 gets 0, because 0, 0 and log 1 is 0. So let's go ahead. So therefore it will gives you sorry, this is having a plus sign. I made mistake. Just check that. So this is 3 ln 3 minus 2, and that's it. So that's the answer for this problem. But see that here we don't see any problem or anything answer matched with that, right? So therefore we can see that is there any way, right? So obviously we see that in this particular case, right, 3 log 3 minus 2 is the correct answer. But here there is some tricks are there. Let's go ahead and check that as well. See that here 3 ln 3 and 2, if I go ahead, we can write it as ln 3 cube minus log of e square. Because e is the base, so e square you can write. So what happened? It gives you 27, 3, 9 and 27. So therefore it can be written as log of 27 by e square, right? And hence we can see that my required value of p is equal to 27 by e square. And see that sometime, right, sometime we made that mistake. What I forcefully did it here, okay? What? See that here log p is written, right? But we always missed that case when time of exam, and that's why this option is present in your case, that 3 log 3 minus 2, right? Because whenever we do any MCQ type problems, we generally do all the calculation in rough work. So then we miss that we are actually calculating log of p, we are actually calculating ln of p, but we are required to find out p. So what is the exact value of p? The p is 27 by e square, and that's why option B is the correct option here, and that's it. Okay, so that's the problem where we find out the limit using integration approach. That's it. Hope you understood the problem. Thank you. Hi all. See this in this particular problem, it's a simple differential equation solving, right? So you have to consider the differential equation and solve that. So first our job is to considering the differential equation. So let's consider it and solve that. So here we have y multiplied by 1 plus xy dx is equal to x dy. So let us try to calculate first what is dy by dx. So that gives you as y multiplied by 1 plus xy and divided by x. So it can be written as y by x multiplied by 1 plus xy. So that's it. Now, this kind of differential equation can be solved by substituting y equal to vx, though it's may not be homogeneous, right? We already learned that, but here we use that as a substitution, okay? So, let us take that. Let y is equal to vx. Now, if I consider that, so therefore it's implied that dy by dx is equal to v plus x dv dx. Let's go ahead that. So therefore the given equation can be reduced as to instead of dy dx, we write x dv dx. And y by x is v and 1 plus vx square. That gives you v plus v square x square. So therefore v get cancelled from the both sides. So we'll have x dv dx is equal to v square x square. So that's it. So that's the first step of our problem. That's the first step of our problem. Now our job is to integrate it. So see now, we already get that some kind of a dv dx form and all that stuff, where we can cancel x from both sides now. So therefore, we can imply that dv by dx is equal to v square x, right? So therefore, from that equation, we can find dv by v square is equal to x dx. That's very simple way we can write v to the power minus 2 dv is equal to x dx. Now we'll integrate both sides. So if I integrate both sides, we'll have v to the power minus 2 plus 1 divided by minus 2 plus 1 is equal to x squared divided by 2 plus c. Therefore, we'll get it as this is minus 1 by v is equal to x squared divided by 2 plus c. That imply that what is 1 by v? We consider that y is equal to vx, right? So therefore we can say y by x is equal to v. So therefore x by y. So therefore we can say minus x divided by y is equal to x squared by 2 plus c. So that's the general solution of the given differential equation. Now it says that the given differential equation is passing through, or the fx is passing through, or the y equal to fx passing through the point 1 minus 1. So therefore 1 minus 1 is a point here. So therefore we'll say that 1 minus 1 is a point on the curve 1, where this is, let us put that equation number 1. So therefore we can say that minus 1 by minus 1 is equal to 1 by 2 plus c. That's imply that c is equal to minus get plus, so 1 minus 1 by 2, that gives you half. So therefore, we can say that a particular solution or in this case, the typical curve that gives you minus x by y is equal to x squared divided by 2 plus 1 by 2, okay? That's it. So that's imply that minus x by y is equal to x squared plus 1 divided by 2. That's imply that y is equal to minus of 2x divided by x squared plus 1. So that's the equation of a curve. Now, in that particular problem, in this particular problem, what we are going to find out? We are going to find out that f of minus half. So therefore, this is my fx, right? So therefore, we go ahead and calculate that f of minus half. That is actually the function value of y at minus half. So you substitute x is equal to minus half. That gives you 2 into minus half divided by 1 by 4 plus 1. So therefore it gives you actually minus minus 1, this is 5 by 4, and that's why the final answer is 4 by 5, and that's why 4 by 5 is the correct answer. So as that here, obviously the option D is the correct answer, and that's it. Hope you understood the problem. Thank you. See this, in this particular problem, we are required to find the solution of these equations, okay? And it's given that solution lies between this 0 to 2 pi. So you'll see that later, okay? So first we need to simplify this equation and then we'll go ahead. So let's go ahead and simplify this. So equation, let us write at cos x cos 2x. Sorry, it's cos only. I just wrote it as a something else. So it's cos x plus cos 2x plus cos 3x plus cos 4x, and that's it's equal to 0. Now see that if I trying to apply and add them, right, we cannot add them directly, because if I apply the formula of cos a plus b, we take cos x plus 2x 3x, and then we have the subtraction x, so we don't get any common. So therefore we just grouped it as cos x plus cos 4x and 2 and 3 separately. So that's equal to 0. Now we need to apply that cos A cos B formula, or cos A plus cos B formula. What is cos A plus cos B formula? Let's apply that. So therefore it gives you that 2 times of cos 4x. So 4x plus x, that is 5x by 2. Cos 4x minus x, that's 3x. So cos 3x by 2. Now let's go ahead and do the next one. So that's 2 cos 3 plus 2, that is 5x divided by 2, and cos 3x minus 2x, that is x by 2, and that's equal to 0. We can say that 2 get cancelled and cos x by 2 can be common. So therefore it's having cos 5x divided by 2. We have cos 3x by 2 and cos x by 2. That's it. So one factor is already came out. Now we need to write down again in a factor form, because then only we can solve this problem, right? So let's go ahead. So it is again cos A plus cos B. What is the formula that we'll use? That cos A plus cos B formula. Let's we apply that. So that's imply that it is cos 5x divided by 2, and whatever there inside the bracket, that can be written as 2 cos x and cos x by 2, and that's equal to 0. Okay, so you just apply that. Now obviously 2 get cancelled out, so therefore our final answer says that it is cos 5x divided by 2 cos x and cos x by 2. That's equal to 0. So therefore, the general solution says that either cos 5x by 2 equal to 0, that's imply that 5x by 2 is equal to 2n plus 1 multiplied by pi by 2. That's imply that x is equal to 2n plus 1 pi divided by 5. The next one is says that cos x is equal to 0. That means that x is equal to 2m, let us take 2m plus 1 multiplied by pi by 2. Next one says that cos x by 2 is equal to 0. That's imply x by 2 is equal to 2k plus 1 pi by 2. That's imply that x is equal to 2k plus 1 pi. So these are the solutions of these equations. Now say that here what is m, n and k? They are integers, right? So here I just consider that here m, n and k belongs to the set of integer. Okay, now we need to calculate those values and we have to count it. So first we consider that x equal to 2n plus 1, and let's see that. Okay, so therefore x, so if I substitute n equal to 0, we get pi by 5. If n equal to 1, then we get it as 3 pi divided by 5. If I substitute n equal to 2, we get it as pi. N equal to 3, we get 7 pi divided by 5, right? If I substitute n equal to 4, we get it as 9 pi divided by 5. If I substitute n equal to 5, we get it as 11 pi by 5. But 11 pi by 5 is actually outside 2 pi, right? So therefore greater than 2 pi. So now we stopped it. Okay. Now let's go ahead and take second one, right? So for that second one, right, x is equal to we just say substitute m equal to 0, we'll get it as pi by 2. We substitute k equal to m equal to 1, that case 3 pi by 2. If I substitute n equal to 2, it's actually 5 pi by 2, that's again greater than. So that's it. Go ahead for the second equation, third one. So in third one, we can get it as x is equal to k equal to 0, we get pi. K equal to 1, we get 3 pi. So again, it is increased 0. So that is the solution. But observe that this pi is already calculated here. So how many solutions are there? 1, 2, 3, 4, 5, 6 and 7. So therefore 7 solutions are possible inside that interval, and that's why for this problem option C is the correct answer. And that's it. Hope you understood the problem. Thank you. Hi all. See this, in this particular problem we are required to find out this sum, and see that this problem is little bigger, right, because everything are there, right. So to solve that we considered few things, right. So first we consider that in this particular case a k minus 1 is equal to that whatever there inside, right, that we consider, and the next step is depends on k, so I consider a k, that is pi by 4 and k pi by 6, okay. That's it. So therefore, that given summation will be now reduces to sine k ak minus 1 and sine ak. We have to do this kind of tricks in exam as well, because how many times you write pi by 4, k minus 1, all that. So here you will spend lot of times there. Okay. Now see that we have to observe something. So let's observe that. So here we can observe that if I subtract that multiplied by 2 here, right, we get 1 by 2. So this is the tricks to solve this problem. Why I apply these tricks? We apply that because if we see that if I consider that subtraction between ak and a minus 1 will get pi by 6, and what's that? That gives you, as if I take sine both sides, that gives you half, because sine pi by 6 sine 30 is equal to half. So therefore wherever we get half, that can be now replaced by sine ak and k minus 1. So this is the simple tricks we have to use to solve this problem. Now it is a formula of sine a in minus b, so we just expand that numerator by sine a, sine b, sine a cos b, cos a sine b form. Now see that we can easily divide the terms, right. So for the first term sine ak and sine ak get cancelled, we get cot term. So cot ak minus 1 and cot ak, right. So this gives you the summation, and summation is from k equal to 1 to 13. Okay. So that's it. Now observe carefully. Now if I write down that, so that means you have to substitute for k equal to 1, that means a0 minus a1, then a1 minus a2, and so on, right. So therefore if I write down and write all the terms using that expansion of summation, right, we can see that few terms get cancelled out. So see that cot a1 will be cancelled here, right. So this term, last term and first term get cancelled, last term and first term get cancelled, and so on. So therefore at the end we'll have cot a0 term and cot a13 term. So these terms are there. If we see that, we just use some cut. So cot a1 and cot a1 get cancelled, cot a2 will be cancelled by the next term, cot a3 will be cancelled by the next term, and cot a12 will be cancelled by the last term of the previous one, right. So by this way all the term get cancelled. So what is left? That is cot a0 and cot a13. So therefore we just write down that, and that gives me the final summation. So now we are done with this sum. So our job of summation is over now. Now we need to calculate what is cot a0 and what is cot a13. So look carefully. What is cot a0? That means I have to substitute k equal to 0. So that means it gives you pi by 4, right? And if I substitute k equal to 13, we'll get it as 13 pi by 6, right? So that's actually gives you my a0 and a13. So obviously cot a0, that means we'll need to calculate cot pi by 4, and that gives you 1. Okay, everybody knows about that, right? So therefore we can say that cot a0 is equal to 1. Now we need to calculate cot a13. Cot a13 will be cot pi by 4 plus 13 by 6. Yes, we can leave as it is, but obviously here we are looking for a numeric kind of answer, so we cannot write down cot pi by 4 is the answer, right? Now see that if I look carefully, that 13 pi by 6, it can be written as 2 pi plus pi by 6. So let's go ahead. Now we see that it is 2 pi plus theta, right? What is theta? Pi by 4 plus pi by 6. So therefore this one can easily be written as cot of pi by 4 plus pi by 6, right? Now what is cot pi by 4 by pi by 6? That can be easily written as 1 by tan pi by 4 plus pi by 6. Now tan pi by 4 plus pi by 6, we can know the formula. So if we apply that formula, it will be the reciprocal of that tan a plus b formula, right? Now we know every values, right? So tan pi by 4 1, tan pi by 6 1 by root 3 and all that. Multiply the denominator and numerator by root 3, we get a simple form. Now we can skip it as it is, but still we in maths we don't do that, right? So therefore we have to rationalize it. We multiply both sides of the numerator and denominator by root 3 minus 1. So we get it as root 3 minus 1 whole square divided by 3 minus 1, the basic calculation. So therefore we can expand that, divided by that, and we get that answer of cot A13 is equal to 2 minus root 3. That's it. Now what is our S, right? Let's recall that. So our S, we calculate that 2 times of A0 minus A13 obviously with cot. Here we already calculating that. So here we can calculate S as 1 minus cot A0 minus cot 13. That gives you as actually that 1 minus 2 root 3. Okay, see this. This is the final sum right now. So obviously now the basic arithmetic give us the result, right? So the basic arithmetic gives that it is 2 root 3 minus 1, right? Because it is having that product and we can easily calculate that. Hence, we can easily observe that for this particular problem, obviously option C is the correct answer. And that's it. Hope you understood the problem. It's a very straightforward calculation, but only we have to apply a small tricks in the second line, that we take 2 commons and write 1 by 2 in the numerator. If you write down that, the remaining problem is very easy. That's it. Hope you understood it. Thank you.